So, welcome back. Uh, Taking it further from the last snippet, we introduced the term quality. Let us again refer to this word quality of a mixture. Also understand the quality and the dryness fraction. The next word, the other word for quality is what we call as dryness fraction. We will see how to compute a dryness fraction, that is calculation of dryness fraction, and also we come to the state of a mixture now at the end. Let us first see quality of a mixture. The quality of a mixture can again be seen from a PT diagram. We are talking about quality. Whenever I say quality, it is related to the two phase mixture or the mixture which is inside the dome or any system which lies inside the dome, alright, not outside the dome, not on the lines, but inside the dome now in the two phase mixture. So, whenever I say two phase mixture, the two phase mixture lies on this saturated liquid vapor line. I am considering a point, the system which lies on this point, and this is my two phase zone. The same thing I can see from the PV diagram, and on the PV diagram what you see again is a saturated liquid line, saturated vapor line. Very important to see that the saturated liquid F point as shown over here is 100% liquid, alright, and the property of this 100% liquid can be obtained directly from the steam table as we know. Similarly, I got a saturated vapor line now here on the dome itself, and the properties related to this G point which is 100% vapor also can be obtained directly from table 1 or 2 or even table 3. So, for any pressure, if I know the T sat value for this pressure, at T sat you can get the values of F point and the values at G point, the properties at F point and the properties at G point. The point is how to get the values inside this between F and G, and that is the most crucial. So, any point here in between F and G which is going to be a two phase mixture. When I say two phase mixture means I got liquid and vapor staying together, liquid and vapor coexisting together, liquid and vapor at the same pressure and at the same temperature. So, this shows that if this point is closer to this, I got more liquid and some little bit of vapor. Here I can see that there is a 50% vapor and 50% liquid, and the vapor region is increasing on this side, and on the rightmost side you can see 100% vapor. So, when I travel from 100% liquid to 100% vapor, the amount of liquid will go on getting reduced, isn't it? This is completely latent phase transformation from 100% liquid to 100% vapor, and as you come from left side to the right side, 100% liquid to 100% vapor, the amount of liquid will go on getting evaporated or vaporized. So, more liquid, less vapor, both are around approximately 50%, more vaporized portion over here or volume has come to liquid, and here you got 100% vapor. Accordingly, the properties at this point F to G would change depending on how much liquid is there, how much vapor is there, the properties are going to change, and that is what is going to be decided by quality. The point is, how do I calculate these properties? That is the most important thing. How do I get values, thermal energy, specific volume, enthalpy, entropy for a mixture? The steam table gives the values for this point and this point. How do I get the values? How do I get all the properties for this region, for the two phase region? And that is the question now that we are going to answer. Importantly now, we are going to talk about dryness fraction, or sometimes also it is called as quality. Quality is also referred to as dryness fraction, and this dryness fraction is defined as X, alright. What is this dryness fraction? It is the ratio of mass of vapor to the total mass of mixture. So, depending on amount of vapor that it has in a liquid plus vapor region, how much vapor is there, this quality or X factor or dryness fraction is going to be determined, alright. So, mass of vapor divided by total mass of mixture is what will be termed as X or dryness fraction. You can see both of these masses, therefore, it is a ratio of two masses basically. So, dryness fraction is mass of vapor which is mg, alright. The vapor will have the same characteristic as G point over here, while the mass of liquid is going to have the same characteristic as F over here. So, mass of vapor mg divided by total mass. The total mass will be comprised of mass of liquid and mass of vapor, and therefore I can define now X is equal to mg upon mf plus mg. Mg is the mass of vapor, mf plus mg is the mass of total mass of the mixture. Now if I try to apply this definition to this diagram, alright, to this diagram, I can now apply to point F, point G and any point intermediate to F and G. If I go by the basic definition of dryness fraction or quality, or sometimes referred to as X only, I can calculate this factor at various points. For example, at point F, what UI is 100% mf, that means the entire mass of vapor is going to be equal to 0 in this case, because the entire mass is liquid mass, right. So if I do that, in this case I will have mg is equal to 0, and therefore my X in that case for 100% mf is going to be equal to 0, and I can therefore say that X is equal to 0 for point F, which is 100% mf or 100% liquid. This is the extreme case. The other extreme case is the point G, where the entire mass is going to be gas, 100% gas on the saturated vapor line, and therefore mf will be equal to 0 in that case. In that case, what is the value of X will be 100% mg, alright. So mg upon mg, because mf is going to be equal to 0 in that case. In that case my X factor is going to be equal to 1 or 100%. So these are the two extreme cases. Any point on the saturated liquid, X is equal to 0, any point on the saturated vapor, X is equal to 1. It means that as I go from the left to the right side, the vapor percentage is going to go on increasing, and therefore the X value will increase from 0 to 1. 0 is the extreme case, 1 is an extreme case. Any point in between 0 and 1 is going to be a two-phase mixture. When you got a X value which lies between 0 and 1, I am for sure know that it is going to be a two-phase mixture. It has got some vapor, it has got some liquid. But the moment I know that X is equal to 0, I know it is a saturated liquid. The moment I know that X is equal to 1, it is going to be a saturated vapor case. So anything in between, I will have a point which has got X value which lie between 0 to 1. So I can conclude from here that from F to G, from saturated liquid to saturated vapor region, I can say 0 is less than equal to X less than equal to 1. That means X value can extreme case be 0 and 1, and in between it will have 0.1, 0.2, 0.3, 0.4, 0.1 to 0.99 is what the X value can have, alright. And therefore whenever X is between 0 to 1, I know that it is a two-phase mixture. It is a very important parameter which helps us to calculate the properties of a two-phase mixture. Thank you very much.